Hi everyone. I'm going to discuss to you about the primal condition or in the consumer behavior that is utility maximization. Now, the basic assumption of the theory of consumer behavior is that we as rational consumers seeks to maximize utility and as we all know that the prices of goods and our income are subject to our limitation. So we can express the concept of consumer choice as a constraint optimization problem. Now, since the main goal or the main objective of the consumer is to maximize our utility, so we must have the utility function that is expressed as u is equals to, or the utility is a function, let's say we have good x and good y. So we must assume here that we should have two goods in the market for simplicity purposes, and this one is the objective function. Okay, so as I've said that the consumer or the consumer's limitation must be subject to our income, which is equivalent to the price of x multiplied by the amount of good x plus the price of y multiplied by the amount of getting y. So our main goal here as a consumer, or the goals that we're going to target here, is that we must able to find out what would be the amount of y that the consumer must able to purchase, so as with the amount of good x. And also with addition, we're going to identify the level of satisfaction or utility and what we call lambda, or this lambda is what we call the Lagrange multiplier or Lagrangian multiplier. Okay, now for us to target these goals, we must use the what we call Lagrangian multiplier method. So what are we going to do is step 1, we must set up the what we call Lagrangian equation. To do so, we first set the constraint function that is equal to 0, since this is our constraint function. So we must set this constraint function equal to 0, so that is I must be minus this one minus this one, then equal to 0. And then we must multiply this form by lambda and take note this is our lambda, to form a Lagrangian equation. Now, the Lagrangian equation is expressed as this symbol, then that is equal to the objective function plus the lambda, then multiply it to our constraint function. For us to construct a Lagrangian equation, so we need to do this. So this symbol, which is equals to the objective function, which is this one. Okay, so it's u, or equals to this one. So u is a function of x and y plus our lambda multiply to this one that we set a while ago, I minus px x minus py y. So after we able to construct a Lagrangian equation, the next procedure, the next step is we must determine the first order condition. Or in short, FOC or FOC's conditions. So let's recall that in our Lagrangian equation, we have possible two variables. One is for x, y, and the lambda. Recall lang natin that doing or to get the first order condition or the first order in calculus, if we have three variables, so it is expected that our partial derivatives in this case is 3 or 3 partial derivatives because of 3 variables. So our first condition based on our Lagrangian equation, which is this partial derivative of L with respect to x. So that is equivalent to, so if we try to look at the Lagrangian equation, so it is partial derivative of u with respect to x minus, so here we must focus on the x, not other variables. So it is expected that we have lambda p sub x is equals to, don't forget that we must set to 0. Okay, then the second FOC, we have partial derivative of L with respect to y, which is equals to partial derivative of u with respect to y minus lambda p y is equals to 0. And then the third is partial derivative of L with respect to lambda, which is equivalent to the second rule in basic, that if constant multiplied by the variable is simply the constant, not the variable. So So we have I minus, then pxx, then minus pyy, which is equals to 0. So in short, yung nasa loob, ilagay na lang natin kasi alam naman natin na itong ating lambda is the variable. Then ito constant term naman. So everything is here should be the third FOC that we have. The first order condition and the second order condition, actually we can get the what we call the marginal rate of substitution of x for y. How? By dividing these two FOCs. So if we divide, for us to get the MRS or even the relative price or the slope of the budget line, we can do this. Okay, so this is the marginal utility of x, if we recall. Then i-transpose ko na lang sa kabila, so this will become lambda px. Then the second FOC, we have partial derivative of u with respect to y. Then i-transpose ko na dito sa kabila, this will become like this. So this is, if we have mu sub x or the marginal utility of x, we have also marginal utility for y. Then if we cancel these two lambdas, so we have the relative price or the slope of our budget line, and this is the MRS of x for y. Okay, so therefore since this is our mu sub x over mu sub y, which is equals to the price of x over the price of y, then to get the utility maximization, so we'll do simultaneously. So let's say mu sub x, do the cross multiplication mu y dx, then multiplied by 1 over, let's say, px. Then the result here is mu x py divided by px is equals to mu y. Then if we multiply both sides by 1 over py, so this will become, and this will be cancelled out. So at the left side, the remaining would be this one, is equals to mu y. So this is now our utility maximization condition. So this must be followed so that we could get the goals here. And recall that if we do this graphically, if this is the x and the y, or the good x and the good y, if this is our budget line, which is I is equals to pxx plus pyy, then we have the indifference curve, which is xy. Then this is our target, so we must solve the amounts of x and y in this case. So let's have our example. Let's say our objective function, we have to maximize, let's say u is equals to x raised to 0.5 times y raised to 0.5. Then our constraint, and we must subject to, let's say 800, which is the income, is equals to the price of good x times the amount of x plus, let's say 1 is our p sub y, then multiply it to y. So our first step here is to formulate or construct a Lagrangian equation. So it is L is equals to our objective function, which is x raised to 0.5 multiplied by y raised to 0.5 plus our lambda, which is 800 minus 4x minus y. Then next step, which is the FOCs. So we have 3 FOCs here. So our first FOC is that partial derivative of L with respect to x, which is equivalent to, so focus on the variable x. So we're doing the partial derivative, then it is 0.5 x. Power rule, we must set our exponent 0.5 minus 1, then copy y raised to 0.5. And then here, ang ginawa natin, nag-construct tayong ganito. So kung ating i-multiply ito, magiging lambda 800 minus lambda 4x ito minus lambda y. Okay. Ngayon, as I've said, you need to focus on the variable x. Ito. So ano mangyari dito sa dalawa dito? So wag muna nang sila ilagay dito sa ating first order condition. So ito ang focus natin. So kukunin mo yung kanyang derivative, and this will become what? Minus lambda 4 x. So it is expected na may 1 ito na exponent minus 1. Okay, and we must set it into 0. Then and this will become 0.5 x. 0.5 minus 1, it is negative 0.5. Then copy minus lambda 4. So take note that if we have 1 minus 1, this is equals to 0, and x raised to 0 is 1. So there's no need for me to put 1. See, it's understood that we have 1 here. And don't forget to include 0. That is our first order condition. Pwede mo baliktarin ito lang dahil lagay sa likod, pwede ito sa harap. So it's up to you. Next, our second first order condition, we have this with respect to y. Then concentrate on this Lagrangian equation. Then focus natin si y. So since may exponent si y na 0.5, so ang kanyang exponent ilagay mo dito as coefficient na, then copy x raised to 0.5, then y. Don't forget that we're going to subtract the exponent to 1 plus lambda, then concentrate to our y. So hindi na ito isasali at ito, kaya it is lambda y 1 minus 1, which is equal to 0. Then simplify 0.5x raised to 0.5 y. 0.5 minus 1, it's negative 0.5. So ito pala is, ito pala is minus kasi minus dito. Okay? Then minus lambda. Ito magiging 1 na. So lambda times 1, it is lambda, which is equals to 0. Next, our third condition, or the FOC subject to lambda. Then if we try to look at this term, ang constant dito is itong nandito sa loob, so ilagay na lang natin. Yan, which is equals to 0. After this, we're going to equate. That's the step 2. So we must equate both lambdas. Saan matatagpuan itong lambdas? Ang lambdas natin matatagpuan dito sa first order condition and the second order condition. Gagamitin natin itong dalawa para makuha na natin yung utility maximization condition na while ago. Ngayon, itong ibase natin. So equate natin to, but before we do the bago natin i-equate ito, kailangan natin na ilabas muna natin itong lambda natin. So magiging 0.5x raised to 0.5 y 0.5, then equals to lambda 4. Then divide both sides by 4. So we have lambda 0.5x raised to negative 0.5 y raised to 0.5. Divide it by 4. So ito yung first lambda natin. Then the second lambda, to. So ito. So ilabas natin si lambda to the right side. So magiging 0.5x raised to 0.5 y raised to negative 0.5 is equals to lambda. Okay. Saka na natin i-equate. So equate natin ito. Equate. So ang first lambda natin is ito. Let's copy. Over 4 is equals to this one. Yan. Then after this, do the cross multiplication. Magiging 0.5 x raised to negative 0.5 y raised to 0.5. So ito ilagay natin dito sa ilalim na. Equals, so ito i-cross mo papunta doon sa kabila, so 4. Yan. Then simplify. Actually ito nandito na tayo sa tinatawag na mux over muy is equals to px py. Yan, ganyan na siya. Ngayon kukunin natin yung mrs nito, no? So i-simplify natin to. This will be cancelled out kasi maging 1 na yun to. Then kapag meron tayong negative exponent, recall, now let's say we have x raised to negative 0.5, ang gagawin mo is what? Magiging 1 over x raised to 0.5. So magiging positive exponent na siya kung ilagay siya sa denominator. So ganun din ang gagawin natin. Kapag nasa itaas ito, ilagay sa baba ang x raised to 0.5. Ito ilalagay natin sa itaas. Ang may iwan dito sa itaas, ito. Then ito ilagay sa itaas din. Okay. Sa baba, ito copy. Ang mangyari dito sa itaas na may negative exponent, ilagay dito sa baba. Then equals to 4. If we multiply this one, so magiging y over ito magiging x is equals to 4. Don't forget here, kapag meron tayong same, or should I say if we have same variables and if we're going to multiply it, then we must add the exponent. Okay? Kaya nagiging 0.5 plus 0.5, same variable sila, therefore it is y raised to 1 actually, or wala na. And ito din 0.5 plus 0.5 magiging ito na 1. So y over x is equals to 4, and this is actually the MRS of x for y, and this is the relative price or the slope of the budget line. Ayan. Ngayon, ito gagamitin natin later on doon sa FOC number 3, no? Para gawin yan, kailangan na isolve ko muna yung y. So magiging 4x, diba? So i-cross multiply mo lang, so magiging 4x na, so maiwan ito. Okay? Mas madali sa akin na kunin itong y kaysa sa x. So ito later on gagamitin natin ito for the next step. So take note that our third FOC natin is ito. So gamitin ko na ito doon, i-apply ko siya dito. Itong kinuha ko, so i-substitute ko ang y dito na. Okay. So sa third step natin is step 3. We can now get the amount of y and the amount of x. Since this is our third FOC, 800 minus 4x minus y is equals to 0. Then our sa step 2 natin, we come up with this. So we're going to substitute the value of y. So 800 minus 4x minus, so since y is equals to 4x, so si y gawin natin 4x, which is equals to 0. Then simplify, this will become 800 minus 8x is equals to 0. Then 800 equals to 8x. Then divide it both sides by 8. So ito na yung sinasabi natin na x asterisk. Then 800 divided by 8. So we now have 100. So the amount of X that the consumer should able to purchase is 100 units. And this is actually called the Marshallian demand for X. The Marshallian demand tells us that our demand has two effects. We have income effect and the substitution effect. Okay. So this is the principle behind the Marshallian demand. So if we're going to purchase 100 as our demand for X, then we consider our income and also substitution of Y for X. Kapag, let's say for example, kung ang presyo ng Y is, let's say, greater compared to the price of X, therefore the consumer will substitute the amount of Y for X kasi mas cheaper ang X compared sa Y. So nagkakaroon ng substitution effect. Okay, so income and substitution effect ang i-consider ni Marshall for the demand. Then for us to get the Y, take note that ito yung na-derive natin. Then gagamitin na lang natin ito para makuha ang Y since meron tayong value na X which is a while ago 100. So gagamitin na lang natin ito. So this will become Y is equals to 4 times ito, 100. Therefore, our good Y is equals to 400 units. This is also called Marshallian demand for Y. Nakuha na natin yung goals, which are the amount of X and the amount of Y. Ngayon, meron pa tayong dalawa na hinahanap, yung dalawang goals to get the level of utility and itong lambda. By the way, ang lambda natin is interpret as that for every peso increase in the income, the ability or the level of our income will increase, or should I say the level of utility will increase by amount of our or any amount of util. Para lang din yun siyang slope, no? So I repeat, for every peso increase in income, therefore the utility level will increase by amount of util. Kung kukunin natin ito, so ang unit of measurement na gagamitin natin is util. Kung ito naman, lambda, ang kanyang unit of measurement is also util. Okay. So that's next our step number 4. Is to get the utility level and the lambda. How do we get the utility, or in this U asterisk? Recall that ang ating utility function is ito. Okay. Since meron na tayong value ng x, value ng y, so makukuha na natin itong utility level. So let's copy. U asterisk is equals to x asterisk raised to 0.5, y asterisk raised to 0.5. Nilagay ko asterisk to denote that we are now on the maximization. So this is expressed as u asterisk equals to, remember our good x result is 100 raised to 0.5 times the result of our good y is 400 raised to 0.5. Then we must use the calculator para madali na lang natin siya makuha ang utility level. So kung meron kayong natural display, madali lang kasi kopyahin mo lang ito, no? Okay, kung hindi naman, so kailangan na be careful kayo sometimes. So kapag sa calculator, ang exponent dito dapat i-open close parenthesis mo. Okay, ito. So sa akin, gumagamit ako na natural display, so madali na lang. So kopyahin ko na lang. So like this. Open close 100 raised to 0.5, then open close 400 close parenthesis raised to 0.5, okay, equals, so I have 200 utils. So how do we able to interpret our utility, which is 200 utils? So this is the level of satisfaction that the consumer should maximize on getting good x and good y. And the last goal that we need to solve is the lambda, which is our step, it's already step 4. So take note that our lambda nandoon sa ating FOCs. So nandito actually na sa step number 2 na ginawa natin. Okay. Ngayon, once we able to compute the two lambdas, dapat ang result nito, both are the same. Kapag hindi magkapareho ang ating lambda dito sa kabila at saka iba dito, then there is something wrong with the computation. So balikan ninyo yung procedure from step 1 up to the last. So kopyahin natin to. So we must see to it na pareho, no? So it's 0.5 x okay. So sa kabila, so 0.5x, 0.5y, and okay. Since meron na tayong value ng x and y, madali na lang siya. I-substitute mo na lang. So, 0.5 times 100 raised to negative 0.5 y, which is 400 now, raised to 0.5 over 4. Then, using the calculator, 0.5 times 100 raised to negative 0.5, then 400 raised to 0.5, then so okay, sorry. So, ulitin ko, 0.5 raised to 100 raised to negative 0.5, then 400 raised to 0.5, yan, then 4, which is equals to 1/4, or it is 0.25 util. So sa kabila, this will become 0.5 100 raised to 0.5 times 400 raised to negative 0.5. Then using the calculator, 0.5 100 raised to 0.5 times 400 raised to 0.5. So this will become, okay, 0.25 util. So you see that we have the same lambdas. So this 0.25 util means that for every peso increase in the income of the consumer, therefore his or her utility increases by 0.25 util. So nakuha na natin yung goals natin, that the value of x is already 100 units, our y is 400 units, our utility level is 200 utils, and our lambda is 0.25 util. Okay. We can check if the amount of getting x and y is correct by using the budget line. So since ang budget line natin is 800 is equals to 4x plus y, then 800 is equals to 4 times, so 100 ito, plus since y is 400, then 800 is equals to 400 plus 400, therefore 800 is equals to 800. So yung income ng consumer is equals to the expenditure that he or she made of purchasing good x and good y. So these amounts are both correct. So ganun lang siya the way we're going to solve for the primal condition, or what we call utility maximization.